how are you all? So here in my today's video, I'm gonna explain to you all one of the question which is from NDA and NA previous year question paper. I already uploaded plenty of the videos on my channel. If you wanted to see this video, you may check it into my playlist. Now let's get started with today's lecture. That I will explain to you all one of the question which is from 2021 NDA and NA question paper. Okay, completely based on a sequence series chapter. Okay. Find out the value for summation n is equal to 1 to 8 n plus 7 I raised to n. Okay, we have to find out the summation. Okay, summation which running from n to n is equal to 1 to 8 n plus 7. Okay, the value which running from 1 to 8 n plus 7 and the value for n which is there in a power of I. Okay, and I here it is given as iota. Okay, iota means it is coming from complex number. Okay, so I which is equal to square root of minus 1. So this is the value for iota that we have to apply here. Okay, now and we have given four options that we have to figure it out the value for summation. First option says that the value for summation -1. Second option says that the value for summation 1. Third option says that value for summation I, and fourth option says that value for summation is negative of I. Okay, now let us see. We'll go through the detailed understanding of our solution. Okay, here we have given n is equal to 1 to 8 n plus 1 summation I raised to n. Okay, and I is given square root of minus 1. Okay, this is the value for iota. Okay, it is same everywhere. Okay, now try to find out what we'll get from this summation. Okay, summation we have here 8n plus 7 till. Okay, so try to expand the summation. What we will get the summation here? Put n is equal to 1, then I raised to 1, which remains only I, plus n is equal to 2 I square. Summation means we have to add all these terms. Okay, plus I cube plus I raised to 4 plus last term we do have here 8n plus 7. So I raised to 8n plus 7. Okay, this is the nth term of our I. Okay, I raised to 8n plus 7. So what we have here, so we can see that the series which it is a similar like a little bit geometric progression. Okay, and when we have ratio between two terms are similar, then we apply geometric progression. Okay, and when we have a difference between two terms similar, we apply arithmetic progression. Okay, so here we have ratio between two terms are similar, but still we need to address some of the term over here. Okay, so how can we see geometric series? Okay, so with the first term I, common difference I, and nth term I raised to 8n plus 7. Okay, and now apply the result for the geometric progression as we saw before. Okay, so for finding sum of a nth term of a geometric progression, we have to apply here. Okay, so this is the required term I common first term into r raised to n minus 1 upon r minus 1. Okay, this is the sum of nth term of our geometric progression. So in order to get the answer, we have to simplify this term further. Now let us see what the next step is coming. So I can write this term as minus 1 and I minus 1 keep it same. So we have to figure it out nth power of I. Okay, so I written I raised to 8n plus 7 as 4 into 2n plus 1 3. Okay, so because we know that the I raised to 4 into n plus r can be written as I raised to r. Okay, that means r into 4n plus 1, it is the term where it always gives the value 1. Okay, so how I have written here 4 into 2n 8n and plus 1 plus 3, which is a 4 plus 3. Okay, which is coming 7. Okay, so this is the power for this. I expanded this way. Now we know that the one result that I raised to, if I write I raised to 4n plus r, so which can be written as r. Okay, I raised to 4n. Why I raised to 4n is 1? Okay, now let me explain why I raised to 4n is 1. Okay, if I write I raised to 4n, take n is equal to 1, so I will get the I raised to 4. Okay, so I raised to 4 means I square into I. Okay, I square into I square, which is I raised to 4. So I square is a minus 1, I square is a minus 1, which comes positive 1. So I raised to 4 which is a 1. Okay, so if you go through the I raised to 8, which is also 1, I raised to 12, it is also 1, I raised to 16, and so on. These all terms are coming 1, value 1. That's why I written I raised to 4 over here. Okay, so that means I raised to 3 minus 1 upon I minus 1, the term which left here. Okay, so here I written this term as I cube minus 1 upon I minus 1. Okay, so I common as it is here, I raised to 3 minus 1 upon I minus 1. Try to solve I cube. So when we know that I square is a minus 1. Okay, so I cube is means I square into I. Okay, so I square is a minus 1 into I, that means minus I. Okay, so I cube, it is coming minus I minus 1, I minus 1 as it is, so I as it is here. Okay, so now multiply I under bracket, so I into minus I, minus of I square, and a minus of I upon I minus 1 as it is. Okay, I square is coming minus 1, so minus 1 and minus plus 1, minus I as it is, and I minus 1 it is. Okay, this is just a calculation part only, so don't get confused. So I minus 1 upon 1 minus I. So what do we do? Try to make numerator denominator same here. So take negative sign common from the numerator. So what we will get here? I minus 1 upon I minus 1 and negative sign common from here. Okay, so I minus 1, I minus 1. So negative common from here. So these two same term get cancelled. We land here with the value negative of 1. And so which is given in our option number A. So option A say that the summation for I raised to n, which is a negative 1. So our option number A, which is a true here. Okay, I hope you all have understood. Quite easy solution, nothing is difficult here. So even if you found anything difficult, okay, let me know in comment section. I will come up with some other videos on it. So thank you everyone. Thank you for my today's lecture.